Hey, Katie.
Hey, Ben.
Did you watch the State of the Union this year?
I I didn't actually. I should, but I
Really?
didn't. I didn't.
Oh, I was hoping you would say yes. I actually didn't watch it either, so that makes us your perfect hosts for this episode about text
State of the Union.
analysis and the
Yeah.
State of the Union. Yeah. So, in any case, you are listening to Linear Digressions.
Yeah, so I confess that I did not watch the State of the Union, but I have the next best thing, which is a really good blog post. This is a little bit of a promotion of one of my colleagues, Mike Heilman. I work with him at Civis Analytics, and he wrote this blog post that is completely amazing about the State of the Union, and I think it's worth looking at, both because there's some really interesting content in there doing analysis of the kinds of things that presidents have talked about over the years, and also as a jumping off point for talking about some topics in natural language processing, which we haven't done very much of in this podcast.
That sounds good. So, is he looking at the topics that are talked about, or the types of language used, or like something else entirely?
Mostly he's looking at topics and how are the topics changing historically.
Huh. Oh, that's interesting.
Yeah. So there are a few things that you need to do in general when you're working with natural language like this to kind of get it into a form that's going to be amenable to machine learning. Because machine learning really likes to have sort of structured inputs. You think about the input to a machine learning algorithm as being something like a vector or a matrix. And text doesn't fit into that mold particularly well. One of the things about text is that sometimes people say things that are very short, sometimes people say things that are very long. And so the length of a message might not be the same across all the different messages that you're interested in analyzing.
We were talking about this with regard to your detector, which you still haven't finished detecting the ums in the podcasts. Of course, we've both gotten quite a bit better at not saying so I don't know, maybe a deprecated project?
I'm not going to lie. The easier way of dealing with ums is just to not say as often.
But the problem there, as I recall, was that ums were of different length. And so you would have short ums, you would have long ums, and there was somewhat of a normalization problem where the algorithm needed to know what an was, but it ideally would be looking at a signal of a certain length, and audio is not very, well suited for that.
Yeah, it's a little tough to be flexible with respect to the size of your inputs. And the way that this is dealt with in text data is that instead of looking at a message sort of in the way that you and I do, looking at the words individually and potentially with things like repetition, also what you do instead is you break the words apart and you use the words individually as a vector. I'm not doing a very good job of explaining this, so let me give you an example. So if I say the sentence like, the cat slept on the bed, then what I would do is the cat slept. Each of those words would be a feature in a vector. And then if you said a different sentence like the cat slept on the couch, then there's going to be a vector that's the cat slept on the, and then where I didn't say the word couch, so there would be sort of a 0 in the vector for my spot where the word couch goes, and then for you, there would be a 1 for the word couch because you say the word couch. And then likewise, I use the word bed, you did not. And so there's going to be a 1 in the column for did this person use the word bed? And there's going to be a 0 for me in the spot for couch. And so then what you get out of that is, this is called a bag of words approach. And the idea is that we're not worried about the order. We're very often also not worried about repetition. So you're just looking at whether a word showed up in the first place or not. And everything gets all jumbled together, but you get an idea of what are the words that this person is saying.
I got it. So you're taking a very narrow approach for what you're looking for rather than looking for what words are used, what repetition is there, what are the order of the words, all that stuff. You're kind of breaking down the problem into just a single problem.
Yeah, and I think bag of words is actually a pretty evocative name for this. It's like, imagine you took all the words that I'm saying and you just put them in a bag together and you shook them around. That's kind of...
and you remove the duplicates.
Yeah, so sometimes there are different ways that you can do bag of words. Sometimes it'll count duplicates. Sometimes it'll just say, does this word show up or not?
Okay.
Yeah.
It's a good name, though.
Yeah. Another thing that usually happens, I should have even said this before we started talking about bag of words. Another thing that's really important is stemming.
So what's stemming?
Stemming is actually finding what we would call linguistically the stem of the word. And what that does is it effectively collapses the vocabulary. So there are something like a few tens of thousands of words in English that you might be interested in saying. But if you take all the different variants, then there can be exponentially more.
So the cat is on the couch, the cat is on the futon, the cat is on the sofa. Those words may, for the purpose of the analysis, be the exact same word. You're talking about where the cat is?
No, actually, although there's a slightly different algorithm that can get in that direction. What I'm talking about is more like, let's say, celebrate and celebration.
Ah, okay. So you're actually talking about the word itself and just different tenses of the word or different forms of the word.
Yeah, and so what they'll do is strip away prefixes, suffixes. There are different kinds of stemmers that have rules for how you sort of transform a word to get it down to its stem, to get it down to just the base word. And then the prefixes and suffixes will change the tense. It'll change the meaning of the word slightly, but you're still sort of saying fundamentally the same thing. And so what stemming does is it allows you to go from typically text data is very high dimensional because there are many different words that we can say. And if you're able to stem, then it'll reduce down that dimensionality a lot without sacrificing too much of the essence, like the core meaning of the things that you're talking about.
That makes sense.
So usually what you do is you stem, you put it into a bag of words. Now, one of the things we said about a bag of words, and one of the drawbacks about a bag of words, is that it doesn't preserve any information about the order. And in general, order can be one of those things that's really tricky to kind of deal with as for machine learning algorithms. And there are ways of doing it. Things like neural nets take into account order, also potentially hidden Markov models. But generally for the simpler types of analyses that you're going to be running, a bag of words is just going to completely disregard order. And that might not be exactly what you want. A straightforward example is that if you have a word and then you also have not, and then that same word, like I am happy, I am not happy. Those are two very different sentences, but a bag of words is going to treat them as actually very, very similar because they share so many words.
So does the bag of words approach have a way to handle that? Things like negation?
Bag of words out of the box does not. What you would do if you wanted to take into account more than one word at a time is you start to move into what we call n-grams. So a bigram model is where instead of looking at all the words, you look at all the pairs of words. So you'll be looking at things like I am not happy. And so there would be several different features that correspond to each of the pairs of words in your sentence instead of each of the words individually. And then trigrams are also another thing that end up getting used. Those are 3-word sequences. And I think in practice, one of the difficulties with working with n-grams, we say n-grams because it is sort of agnostic as to how many words you want in your gram. And n is just a placeholder for what that number is. One of the problems with working with bigrams or trigrams or n-grams, though, is that you begin to start to have very high dimensional data again because each one of these words individually is going to be pretty rare. And then seeing 2 of them in sequence one after the other is going to be that much rarer. And so you start to have very high dimensional data with n-grams. So you have bag of words, you have bigrams, you have trigrams. These are fairly standard things you can do, though, and there are good packages like NLTK in Python that deal with most of the heavy lifting of actually doing this text analysis. And so you shouldn't consider it a trivial problem to deal with, but for the most part, a lot of the most difficult stuff has been sort of solved already, and it's just up to you to import the right library and to do an intelligent thing with it. So the formatting of the data is pretty non-trivial, but there are standard ways to deal with it. So now I want to talk about a little bit what my buddy at Civis did. So he took all of these State of the Union's addresses, he put it in through the stemmer, removed stop words, so get rid of the extremely common words like a, an, the, of, is, 'cause they're just not very interesting words. They don't contain a whole lot of content. And then he put it into a bag of words. And then after getting it into this format, he started to do some simple analytics on what are the kinds of words that get used. In particular, over the course of time, how are the words that get used, how do those change? And are there things that presidents are talking about today that they weren't talking about 100 years ago, and vice versa? So one of the first questions he was interested in is just how much is the language changing over the course of time? And so what he used for this was what's called a cosine similarity metric. So you have these 2 different speeches that have been given by, let's say, Franklin Roosevelt and Barack Obama. And the question that you're trying to ask is how similar are these two speeches to each other? And so you take the two vectors that correspond to all the words that are in both of those speeches, and you take the cosine distance in between them, which is sort of a technical thing, has to do with how many words they share as opposed to how many words they don't share. So if you use the cosine similarity, the closer two speeches are, if you give literally the same speech twice, it's going to have a cosine similarity of 1. And then if we say nothing that's in common, it's going to have a cosine similarity of 0. And so he plots a matrix of all. Yeah.
One quick question. This is with a bag of words, right?
Yes.
And if you give the exact same speech a second time, but you switch the order of the words, that would also have a cosine similarity of 1, right?
Yes.
That's all I wanted to say.
Okay. And so then he plots all of the speeches in a big matrix, or I should say all the cosine similarities, the speech-to-speech cosine similarities in this big matrix. And so there are a few things that, first of all, you're going to get a string of 1s along the diagonal, because the diagonal marks the speeches that are sort of being matched with themselves, and those are always going to have a cosine similarity of 1. And another thing that you start to see is that along the diagonal, there are these blocks that show up, and they're always in the size of either 4 by 4, 8 by 8, or I think just once there was one that was either 12 by 12 or 16 by 16. You want to guess what those are?
The 4 and the 8, that would be presidential terms.
Yeah, so it's that within each president, they tend to talk like themselves, right?
Yeah,
so
they definitely would tend to talk like themselves.
Right, so the things that Obama talks about in 2016 are the same as, or fairly similar to the things he talked about in 2015 and 2014. But then those are, they show some significant differences from the things that, say, Bush was talking about in 2005, let's say. Whereas the stuff that Bush was talking about over the course of his presidency was mostly, again, pretty self-consistent.
That's interesting. So not only are you comparing presidents' speeches against each other's, or against the other presidents, you're also comparing each president's speeches against themselves. So you can even see which presidents had more deviations between their State of the Unions than other presidents.
Yeah, so some of these that I think are really, really interesting. And just by looking visually at this matrix, you can start to see what are some of the outliers. Some big outliers. Bush's State of the Union in 2002. So this was the first State of the Union after the September 11th terrorist attacks. And it was very different from many of the other speeches, because in most of the speeches, they're talking about things like the economy, they're talking about jobs. Before the Civil War, they were talking about foreign policy a lot and tariffs and things like that. But this was a speech that was just all about terrorism. And so it had a markedly different vocabulary from the speeches that we had seen prior to that. And in the later speeches, as the wars in Iraq and Afghanistan were going on, then it started to share a little bit more similarity with that 2002 speech, because it was sort of like there was this new topic that we were talking about. But you could see this big deviation between 2001, the speech in 2001 was given in January, so that was before the attacks, and then the speech in 2002, where all of a sudden the conversation had totally shifted and the vocabulary reflected that. There are some other blocks that start to jump out at us. FDR's presidency was a very specific, had a very sort of specific vocabulary that was attached to it, and this makes a lot of sense because he was talking about the Great Depression and he was talking about World War II, and these are two very distinct and compelling events that happened in the history of the United States, and you can see that there was a very sort of tightly and distinctly clustered set of speeches that were given during his presidency, and they stand out from the entire other corpus of all the other speeches that were being given. They're also kind of interesting because they mark two different eras that you can see in this matrix. So there's a big block of the speeches that were given prior to FDR that were sort of roughly consistent-ish with each other. You could see that from the beginning of the country, the first State of the Union was in 1790 up until FDR. There was a lot of sort of self-consistent speeches that were being given. We were talking about the same thing for 150 years.
Wow.
Then FDR comes along. World War II fundamentally changes the economics of the world and the role that the United States plays in the world. And we start to talk about different things. And so the post-FDR sort of Cold War and forward era has, again, sort of its own vocabulary that's distinctly different from the vocabulary that was being used in the early years of the United States.
Was it Taft who had two terms that were separate from each other?
I think so.
I'm curious if you could also see that in his blocks.
You know, I'm looking at the matrix and I can't quite tell if that's visible because there's been a lot of State of the Union addresses. There's one every year since 1790. And so not every single one of them is labeled. Although in the era that Taft was president, everybody was just saying the same thing anyway. So my guess is that the two separated terms of the Taft presidency were probably very consistent with each other, but they were also probably pretty consistent with the guy who came in between them.
Oh, I'm sorry.
No, it was Grover Cleveland.
Grover Cleveland.
It was Grover Cleveland. I knew that.
Oops.
I knew that.
Yeah, I knew that somewhere in my head too.
So another speech that I think is kind of interesting, Jimmy Carter in 1981. This speech just completely leaps out at you immediately as being very similar with lots and lots of other speeches. So you look at this speech and it's like, oh, this was really similar to a lot of the stuff that Obama speaks about and a lot of stuff that Bush talked about and Clinton and also Kennedy and Eisenhower. Like very high similarity with lots and lots of other State of the Union addresses. Any guesses about what would make something like that happen?
History is not my strong suit. So if it's a historical event, I couldn't tell you.
It's not, actually. What it is that State of the Union's average right now around 5,000 words, maybe.
Uh-huh.
The speech that Carter gave in 1981 was 33,000 words long.
Did he just use up all the words?
And he just used all the words.
Oh my gosh.
Yeah.
That's amazing.
So it ends up being really similar to like everything. It's because he just talked about everything.
Wow. Huh.
And so another thing that we did was looked at the words that are most distinct sort of between some of these big eras. So we said the pre-FDR, the FDR World War II era speeches, and then the post-FDR ones. And you should read the blog post to get sort of all the details. But the short version of it is that before FDR, before 1932, there was a lot of talking about what I would call maybe foreign policy issues and also domestic expansion. So that was the time in which the United States was actually growing as a country. And a lot of the words that were important were things like Mexico, treaty, Spain, territory, public, government. They were working out things like how are we expanding as a country and what's our role in the international sphere. And during FDR's presidency, 1934 to 45, there's a lot of language in particular that reflects speaking about the Depression and the war, obviously, as well. So things like program, economic, democratic, democracy. Those are two words that maybe should have been stemmed, but I think Mike did a fine job. So I'm not going to pick with that too much. Recovery, right. Jobs, dollars, fighting, Japanese, overwhelming, world. So these are, you can start to see both the Great Depression and the war. And then since 1945, there's been much more speaking about jobs. There's been much more speaking about budgets, economic things, and also the pressing international issues of the second half of the 20th century. So things like nuclear, Soviet, energy, American, millions, billions, those sorts of things. So we also are getting an idea not just of, okay, the language has changed, but you can start to see the topics that are important throughout time and also breaking it down sometimes even by presidency. What are the things that Obama talks about? And are those very similar to the things that Bush talked about? Are they maybe more similar to the things that Clinton talked about? Because obviously Obama and Clinton were both Democrats, and Democrats tend to talk about certain issues more than Republicans do. And so through text analysis, you can start to access all of these things. So just to be a little bit more concrete about it, Bush talked about Al-Qaeda and terrorism. Obama talks about jobs, college, business, kids, internet, also Al-Qaeda. And then in 2015, one of his most distinct words was networks. So possibly both networks, things like maybe terrorist networks, but also potentially things like social networks. So you can start to see different issues as they're bubbling up to the forefront of the topics. And the vocabulary of the time, then that can be picked up by these sorts of text analytics methods as well.
So in previous episodes, we've talked about textual analysis for looking at things like the writings of authors from a long time ago and things like that. Things where there's a huge volume of text that you can't necessarily analyze all in your head. Definitely you could, if you really wanted to, go through State of the Unions and manually catalog all of it. But I imagine there are other use cases for this where you just couldn't get through all of it, like congressional records or something like that.
Yeah, absolutely. Absolutely. And you're right that the State of the Union is actually a pretty tractable problem. But if you want to do something like read what's everything that anyone's ever said in Congress about tariffs, that could take you years to get all of that information. But if you feed it into a computer and you start to do things like what are some light topic analysis, what's some light vocabulary analysis, you can start to access that much more quickly and get a very high level view of, what people are talking about.
I love computers. They're just so much faster than us at certain things in particular.
So before we leave, I should just be a little bit repetitive about where you can find this blog post. So this is
redundant too.
The Civis Analytics blog. The way that I found it was Civis Analytics blog and then say State of the Union. And the title is Data Science on State of the Union Addresses, Obama 2016 versus Obama 2015 versus ... versus George Washington 1790. The idea being that he's looking at, the most recent, the second most recent, then all the way down to the very first one that George Washington ever gave. So this is an excellent blog post and has a lot more detail in it than what we've even been able to cover. But so I highly recommend it.
Katie, how many C's and how many S's does Civis have?
Civis is how Civis is spelled.
Cool. Now it's a little easier to Google.
Oh, yeah. Good point.
Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.